One of the biggest challenges with welding aluminum, specifically with MIG, is typically the feeding. With other systems, besides the Fronius push-pull that we have behind us, you run into either bird's nesting or wire slippage. With the Fronius equipment, you actually have a push-pull system which eliminates a lot of those feed-related issues. So you can run softer wires like 4043 and 030, 035 wires, 045 up to 062. A lot of the aluminum that you'll see welded either by hand through spool guns is 047 and 16th. It gets a little bit tougher when you get into the smaller, softer wires to feed. More issues that you run into kind of inherently with aluminum as a material is the oxide layer. So aluminum oxide melts at a temperature range that's about 3 times higher than the base material itself. And cracking through that oxide layer is very crucial to a quality weld. With the Fronius equipment, you have hot start and SFI capability, and also with the I-Wave is the addition of AC. With the Fronius equipment, we do have the hot start SFI capabilities to crack the oxide layer. We also have PMC, CMT, and also the mix processes that go along with those, and ripple drive. You have the AC capability, so it kind of can help with thinner materials and gap bridging, or you can go with, say, a standard universal or a PMC dynamic and get kind of the punch for thicker aluminum materials. CMT is kind of a cooler process, kind of helps more with the thin materials. PMC is a modified pulse. It's called pulse multi-control. So it gives you a little bit more controllability of the heat input than, say, a standard pulse universal line. A little bit less heat input. And then you have, say, the mix processes that will actually have, say on CMT mix would be a PMC hot side, CMT cold side. So you can get kind of the heat punch to get it to wet out, and then kind of the cold side to bridge gaps. And kind of in tandem with that, you can get more of the stack of dimes TIG appearance if you're looking at aesthetics. So in this example, we're going to be using CMT mix, which is mixing PMC with CMT to either give you the stacked dimes appearance or to help with gap bridging and further reduce heat input into the base material while still allowing the weld to wet out and get penetration. So from this, you can see the visual appearance of this, the aesthetic of where you're actually getting the solidification from the low side and getting the stacked appearance fish scale aesthetic. This helps with managing heat input as far as bridging gaps and as well as out of position welding. Either vertical or overhead positions, which are typically not something you see with other equipment. A standard pulse trying to run vertical up would struggle and drop out, whereas a mix process allows that puddle to solidify before you advance your travel speed. In this last example, we're using CMT mix, and you can see that the spacing on the solidification line is tight, which can be fine depending on application, but if you're looking more of an aesthetic with the stack of dimes more spaced out, You have the controllability with the Fronius equipment to control the high side and the low side of that mix process. Going up on the high side will give you a larger dime appearance, and then going up on your low power time correction will increase that spacing or the cool side of the process, allowing you to get, you know, an elongated stack of dimes appearance. So on this example, we're going to go up to say 12 on our low side. So with this, you'll see that your bead is actually narrowed up a little bit more because you're spending less time on the hot side. So your overall heat input is going to be reduced, and your puddle isn't going to be as wide or wet out because your wire feed speed is going to be lower throughout the process, and then your stack of dimes is more apparent. On the second weld that we just did, we increased the low side correction of the CMT mix, allowing for the puddle to solidify and create a more stack dime appearance that's elongated versus the first, which was a short duration or a shorter duration on the low side, and the stack of dimes is actually closer together.